Thank you very much, Catherine. So what we're going to have now is the first of 3 sessions on fostering international collaboration. I'm very pleased to say that we've been able to put together a panel that includes an academic voice, one from the sort of space and commercial realm, and then a sort of governmental voice. So I'm going to be introducing Jonathan McDowell, who is a long-standing friend, an expatriate Brit who's working in the United States. I note that our chairman is an expatriate American working in the United Kingdom. I'm not going to speculate about which country has benefited most from that exchange, because that will get me into trouble. But and then one of my personal heroes, who I'd like to come invite to come and join me up at the front here in person, is Daniel Oltrogge, who's been doing an amazing amount of work on sort of standards and things of that nature over an extended period of time now. So Dan, please come and grab a seat. And then I'll be introducing Natalie Moore from the UK Ministry of Defence, who has the title of Space Policy Director or Head of Space Policy. So she'll provide the sort of governmental voice. But I'd like to start by, if I may, handing the floor to Jonathan, who is very well versed in the sort of subject area of astronomy and the impact that space operations are having on the sustainability of sort of astronomical observations at the moment. So Jonathan, can I hand over to you? Cheers.
Thank you very much, Stuart. You can hear me all right?
We can indeed.
Okay, great. By the way, I know Natalie is having audio issues and can't hear us. So let me try to be really brave and share my screen. Let's see if I can do that. Here we go.
We can see your slides.
Excellent, thank you. So I'm going to be talking about challenges to astronomy from large satellite constellations. So as I'm sure you've probably already heard, we've really got a new era in space utilization with these very, very large constellations. And I just want to remind people that, constellations of satellites, of course, are not new. There are a bunch of constellations that are of order 100 or a couple hundred satellites, some of them quite old. What used to happen in the 70s and 80s is, we have, for example, the Soviet Strela 1M communications constellation, of which there are 360 satellites in orbit. But they only had a few working at any one time, and there was no propulsion, so the old ones just stayed up and are now space debris. And that's sort of rather different from the new constellations, which are at a whole new scale. And so, based on the filings with the FCC and the International Telecommunications Union as of mid-2022, there are several 100,000 satellites expected in the coming decade, 30,000 from the second generation Starlink. At one point, OneWeb was going to have 48,000. They've now reduced that number substantially. But there's a whole bunch of other players who haven't started launching yet. And in particular, there are 3 satellites now in orbit as test satellites for eSpace, but they say they want 300,000, which seems implausible, but that's what the request filing says, and they filed through Rwanda, which seems also a little strange. So the thing about these constellations is that a lot of them are in rather low orbits, and they're quite large satellites. And so already Starlink is dominating the population of big things in the lowest orbits. I'm going to just go over the constellation definition. There's just a visualization of where the Starlinks are distributed over the globe as of a month ago. And the point here is just to show, obviously, the individual satellite dots are not to scale. The point is to show that there's a fairly sharp cutoff at the inclination of the main shells, which is 53 degrees. And so above 53 north or below 53 south, there's only a few. They do have a polar shell, but it's not very populated at the moment. And you'll also notice these trains crossing the globe of sort of streaks of satellites which are still in the process of orbit raising and are still kept quite close together. But it's not just Starlink. It's important to say that, and there are a bunch of new entrants. There's a Chinese constellation that had 6 test satellites launched in March. As I said, eSpace launched 3. Boeing has one of its V-band test satellites up. AST Space Mobile has made the news lately with this enormous Blue Walker 3 satellite, very large communications array illustrated here, that has just been deployed in the past couple of weeks and has been observed by astronomers to be as bright as some of the brighter stars, ranging from magnitude 1 to magnitude 2 at times. And there's a Russian constellation that a test satellite was allegedly launched in October, but after a month still hasn't been tracked by Space Force. So that's a bit of a mystery. And just to sort of go quantitatively into my database to show the impact of this on the space satellite population, what I'm showing here are objects over the past few years, the number of objects that are big, that is to say greater than 100 kilograms, in the lowest, that's to say below 600 kilometers orbits. And the cyan color here is the Starlinks. And so the point of this is to show that there's been transformational change in this big low population in just the last few years. And and that Starlink completely dominates that population. 3/4 of the satellites in this category are Starlinks. And that's including orbital debris. That's totally negligible at this altitude. And so, although, Elon told us when Starlink went up, oh, there's thousands of satellites up there already, so a few more thousand won't make that much difference. But that's very misleading, because most of the 20,000, 25,000 tracked objects are small debris or in high orbits. And so Starlink is already completely dominating the population of big things in the lowest orbits, and therefore dominating the population of bright naked eye objects. And that's with only about 3,000 satellites deployed, compared to the Generation 2 Starlink that's going to be larger satellites and potentially 30,000 of them. And I think it's worth emphasizing, this is a plot of the current distribution of the orbital heights of Starlink satellites. They're meant to be at 550 kilometers, but a significant fraction at any one time is either on the way up or on the way down. So 12% of the constellation is below 500 kilometers, a bunch at 350 doing orbital plane drift. And so when you're assessing the impact of these constellations, you do have to pay attention to the fact that a significant number of them are not in the operational orbit, that actually the fraction that is sort of in orbit raising particularly is really significant. And OneWeb is the other constellation that's been broadly deployed, and a somewhat similar story. Only a few hundred, about 450 deployed so far. And this shows on the right their orbit raising strategy. They get into a 450 kilometer deployment orbit and then raise to this much higher operational orbit of 1,200 kilometers. So with them, it's particularly important that they not have dead in the water type failures that would leave satellites in this high orbit that would take centuries to decay from. But that there is still, again, a significant fraction of the constellation in orbit raising at any one time, and therefore passing through the orbital altitudes of other systems. So for the impact on astronomy, we were slightly shocked after the first Starlink launch. We had not anticipated how bright these satellites were going to be. This is a photo taken the day after the first launch, and we saw these 60 satellites going across our field of view. And being astronomers, we did some math, and well, okay, what happens when there's 100,000 of these? That could actually have quite significant implications for our operations. And now it is true that the satellites became fainter once they switched their operational orientation, put the solar panels to the sun, and then raised their orbits a few hundred kilometers. That brought us a couple magnitudes, but still, they're still quite bright. We did work with SpaceX a lot, and they tried adding visors to the satellites to make them to shield the antennas and make them less reflective. But they had to take those visors off in the latest generation when they added laser crosslinks, so that they got somewhat brighter again. They're using now Bragg reflection filters, Bragg interference filters rather, to make the satellites less shiny, but that's not quite as effective as the visors. So they're not quite as bright as the very first prototypes, but they're still rather bright satellites. And not to pile on Starlink, the point is that this very first observation shows that it's at least now technically possible. If you were like an evil supervillain who wants to destroy the night sky, it's now possible to launch a naked eye constellation that would outnumber the visible stars. If you just leave them in low orbits, and that's a potential change to the night sky for everyone, including non-spacefaring nations that may not have been paying attention to this issue, but may have deep cultural connections to the night sky. So there's this issue of how should this be regulated and how should this be addressed on the international scene. Focusing in on the professional astronomers, more and more frequently, we're seeing these satellite streaks on our image. And often people say, okay, so just use Photoshop to remove the streak. But actually, when we're not just taking pretty pictures, we're trying to measure things like the brightnesses of stars or their shape. Okay, sorry, apparently I've got the wrong zoom set all this time. Bear with me a second. Let me just show back. So you probably didn't see this critical slide showing the 10%, that 12% that are below 500 kilometers. And then is that presented correctly now? I'm hoping it is. Just to say, so to repeat, we're trying to do things like measuring the star brightness to 1% accuracy, measuring the detailed shapes of a galaxy, stuff like that if you just cosmetically fix the visual appearance of the image, that isn't enough. You've compromised the data, especially if there's any scattered light component that affects the background and makes it hard to detect the faintest objects. And you can see, for example, in this bottom left image where you have a tumbling satellite which is repeatedly brightening, that if you had an automatic algorithm trying to sort of discover galaxies, you might well incorrectly discover such objects. So again, just to say, the thing about these new constellation satellites, and in particular the Starlinks, they're big, they're low, and they're shiny. And we can simulate this with showing, this is, I took a sample constellation. This is the original OneWeb phase 2 constellation with 48,000 satellites, which they're not now planning to launch, but it's characteristic of a number of the constellations that are planned. They have 3 shells at 3 different inclinations, and the 3 lower curves show the number above the horizon as a function of Earth latitude. That shows particularly this green one has 2 peaks the number above the horizon peaks slightly below the orbital inclination latitude of the constellation. So when you add them all up, what you tend to see is that the peaks of numbers of satellites above the horizon happen at temperate latitudes. There's slightly fewer at the equator, there's fewer at the poles, but there's a lot at like 30 degrees latitude, which happens to be where a lot of the ground-based observatories are. But it's not enough for them to be above the horizon. You need them to be illuminated by the sun while it's dark where you are. And so that is an easy calculation to do. You just do the geometry of where the sun is, where the satellite is, and so we can sort of simulate the effects of these constellations as a function of time of night. So when I, as an astronomer, go to the mountain and try and start using a telescope, I maybe start as the sun sets doing certain kinds of science. I mostly work on the kind of really deep space science after astronomical twilight, when you see these vertical lines of how far the sun is below the horizon. The last one is 18 degrees below the horizon, which is what we call astronomical twilight and what normal people call the middle of the night. And what you can see is that as you get into astronomical twilight, the number of illuminated satellites, and this is sort of a summation of several of the planned constellations: Starlink, Kuiper, OneWeb, and Guanwang, and so we expect that in the early evening you have about 400 satellites illuminated above 30 degrees above the horizon. So this is not just above the horizon, this is way above the horizon, where a lot of the deep space astronomy happens. And once you get into the middle of the night, that number drops, but only drops to about 100. And that is dominated, if you look at the lower plots of the different constellations, it is dominated by the OneWeb and Guanwang constellations, because they are the ones in higher orbits. And if you're in higher orbits, you are illuminated later into the night because you can see the sun for longer. And so the Starlinks actually don't bother us at midnight in a typical night. It's the OneWebs and the Guanwangs, which are too faint to see with the naked eye, but well bright enough to have a serious effect on astronomical imaging. And the worst case is, however, if you're trying to observe near the horizon during twilight, during the early hours of the evening, when, if you count all the satellites above the horizon, they tend to be concentrated towards the horizon, you can have thousands of illuminated satellites across the sky. And that translates to several expected satellite streaks on every wide field image with a given exposure time. And so what I'm not going to go through this in detail, but you can do a simple equation to estimate how ruined do I expect my image to be, how many streaks crossing it, and it depends on the total number of satellites high in the sky, how fast they're moving across the sky, which depends on their orbit, and how wide your field of view of your telescope is, how long your exposures are. But for typical numbers, that number comes out to be greater than 1 for these proposed constellations, that typically all of your images will be affected. And it's, maybe if it's 1 every 5 images that are affected, you can median filter. But if it's multiple streaks on every image, it becomes very hard to mitigate. So again, higher orbits, each satellite is visible by more observers, a larger fraction of the constellation is visible, and the satellites are illuminated by the sun longer into the night, and the angular velocity is lower, so the surface brightness on your camera pixels of the trailed image is also higher. So all of those mean that higher orbits are worse for the professional observations. If you have very bright satellites, even in lower orbits, they can cause electronic ghosts in your detector, affecting the whole field. I'm just going to skip that. And then if you include this e-space filing of 320,000 proposed satellites, you can see that, again, they're mostly low enough not to, well, it's still several hundred in the middle of the night, but it's thousands illuminated high in the sky above 30 degrees inclination in the twilight hours. So that's going to be drastic. 4,000 satellites above the horizon at midnight in midsummer. You can even have problems with space telescopes. On the right, bottom right here is an image of a Chinese rocket stage that happened to pass quite close to the Hubble Space Telescope, right in the direction it was looking. There's a really nice cluster of galaxies underneath this bright satellite streak. So HST, its orbit is now decayed enough that it is below the Starlink constellation. So Starlinks are passing above it all the time. And we are seeing an increased rate of satellite streaks in Hubble data. Hubble is not as badly affected as some telescopes because it has a narrow field of view. You're going to be more effective if you have a wider field of view, like, for example, the proposed Chinese space telescope that's going up next year. They're going to be really hosed, I think. So we've been working with the American Astronomical Society. We've been working with the International Astronomical Union. We've briefed various US licensing agencies. We've briefed the COPUS. And so going forward, we want to work with the satellite companies on mitigation, but we also need to continue public pressure and work with the UN on the idea that the night sky is part of humanity's heritage and environment, and perhaps even is covered under a space activity in the Outer Space Treaty that might require protection and due regard and all of those good space governance things. Just to summarize, we're really potentially changing both the LEO environment, but also the night sky. The impact on astronomers depends a lot on the orbits and other things. The lower orbit constellations are going to affect the night sky for average people in dark areas, let's say. And the higher constellation shells will be illuminated all night long in summer. And so they're not a threat to the naked eye observer, but they will be a threat to professional astronomy. And as someone noted in the chat, particularly the Vera Rubin telescope, which is going to be significantly affected by this. And I also agree with a comment from Dan Hook that, yes, we are reaching out to indigenous communities who are also, have an interest in this issue. So I'll leave you with this and happy to take any questions. Except that I think I now can't hear. Stuart, can you still hear me? I can see. Yeah.
My mic's on. Do I need to switch it off?
No, that's good. I can hear you. Sorry.
Okay. Yeah. So, Jonathan, if it's okay, we'll take questions at the end of the session after Dan has spoken to us. So Dan is the chief scientist at COMSPOC, so he's the commercial voice on the panel, and Dan has been doing work for many years on trying to get some rules of the road established, and he's going to tell us about where he's reached on that endeavor now. So Dan, over to you. Thank you.
Yeah, thank you very much. Honor to be here. Yep, looks good. This has not been run on this computer, so we're going to do a little experiment. Otherwise, we'll switch to a PDF if fonts change or something. But basically, I'm going to focus a little more on collaboration. And to me, collaboration gets at common terminology, so you can talk about things in a common language. It addresses standards in terms of best practices, and then standards in terms of how you share your data. And then look at some of the standards that we've built that can address space sustainability, et cetera. Next chart, please. This speaks to the terminology aspect. There was an initiative, actually Emma Kerr just left, but she and I are on the IAF Space Traffic Management Working Group. And an earlier working group that I was a part of looked at terminology. And this is kind of the picture that we came up working collaboratively on. Did it have all countries of the Earth participating? No, but I think it had quite a few, the major spacefaring countries. And we have the issues of space domain awareness on the upper left, which gets at security. We have space traffic management, which is talking to short-term safety. And that includes in the middle there, space traffic coordination. A lot of times people are interchanging those terms. And I think being from the US, I can say my take is the US started us off wrong because we called coordination, we called it management. And so that has led to, I think, a long confusion there. But space traffic coordination is a part of space traffic management. And then on the upper right, we have space environment preservation. That's looking at objects in orbit well beyond a mission. And all of those things lay on top of a solid framework, hopefully, of space situational awareness. Next chart. So here's a bunch of words. Not going to dwell on this chart, but point out at the bottom, we have published these results, both through the IAF as well as at technical conferences, and you can see those definitions there. Next, please. Now, this is a chart I like to show to kind of look at our space governance overall. I think a lot of times we say, well, what's better? Should I do this or should I do that? And I have a much different approach to this. I think we need to look holistically at the whole space sustainability and security aspects. And so on the y-axis here, I'm showing things that are kind of top level, maybe vague, if you will, up to the detailed on the upper left there. And then on the x-axis, we've got something non-mandatory over to mandatory. So obviously national regulations are in the upper right. They're detailed, they're specific, and they're mandatory. You have to do them. Treaties are on the right, but typically they're not detailed. They're somewhat vague. They say you must do this sort of thing, and then it's up to the countries, the state actors, to decide how they interpret those things. We have a lot of guidelines, and the most recent one is the UN COPIUS LTS long-term sustainability guidelines, and those are great. Sometimes they're a little more top level. They're not built in a way that's contractually implementable. They're sometimes not verifiable. So standards that I'm going to focus on the rest of the talk here really tries to take guidelines and treaties and whatever else feeds this, including commercial best practices, and codify that into something that you could incorporate into national regulations or contracts, et cetera. Next. Now, where does content for space standards come from? Well, it comes from a whole variety of things. And we heard a nice presentation from Joanne in the last session about new initiatives and best practices they're looking to assemble. I'm seeing more and more of these come up, kind of like popcorn coming from multiple places. And in a way, if you look at the time scale of building United Nations guidelines, it can be kind of glacial. Okay. And so I think it's reasonable for us to focus on maybe like-minded countries or companies coming up with best practices. But ideally, I'd like to see things bubble up, you know, to merge rather than diverge. And there are more and more best practices being assembled. I hope we can continue to merge as we go along. Next. Now, here's another way to look at that puzzle chart, aspirational to normative. But now on the x-axis, we have kind of the two types of standards that I see. One is standardizing your norm of behavior. What am I expected to do if I'm a good operator? The other one is how I exchange data. Next one. So in each of these boxes, you can start to lay down some things. ISO is certainly a standards development group that has normative best practices for satellites. We have a number of ones I want to just mention here. The orbital debris mitigation standard has been in place for quite some time. And the new ones we're working on are a large constellation standard. And by the way, we're using large constellation rather than mega. We've evolved to that terminology for the reasons that Jonathan mentioned earlier. And a space traffic coordination standard. Next. There's a lot of aspirational best practice work being done. Space Safety Coalition, I administer that one, but there's a whole bunch of them listed there, and there's a lot more than listed on this chart. Some people might say, how come I have the IEDC listed there as aspirational? Well, it's because it's guidelines. There's no normative content that is incorporated that you must do. That's where standards can take the IEDC work, codify it in a way that's verifiable and can be enforced. Next one, please. Then on data exchange, we have a lot of standards there. I'm not going to belabor this. Next one. And then on the data exchange aspirational, there's a lot of data being exchanged already in the commercial realm. And it's aspirational. Nobody's forced to do that, but there are areas where that's been standardized. Next. So this just says what standards do. Next one, please. And I'll just say, oh, that little blue thing there. You know, voluntary consensus international standards can overcome a lot of things. You don't have to do them, but if you choose to do them, it can overcome political barriers, etc. And competitive interest is a big one. Next. Now let's go into ISO, International Organization for Standardization. It's the world's largest developer of international standards. And they have 100,000 subject matter experts and 23,000 international standards. Next. But so what? How many of those relate to space? Well, that's this chart. In the technical committee 20 they have, there are a couple of subcommittees, 13 and 14, next, and next, that work on data exchange and best practices. Next. So looking at the data exchange, subcommittee 13, which is operated in duality with CCSDS, that is operated by the space agencies. And there's a couple cool things about that. Because the space agencies work this and fund this, the standards that come out of CCSDS are free. And to me, that's a huge benefit for data exchange standards. And I list some of the messages there. Let's go on to the next chart. You might say, well, where does this fit into a space traffic coordination and management framework? On the bottom left, I have just a notional one, but you see space operators and the center itself, and the tracking entities is that middle left box. They all have to interface somehow. Next one. So over on the right, you see an extremely busy chart, but all those little green circles and ellipses, those are standardized data exchange messages in place. Next. This is an assessment I did earlier this year looking at the CCSDS standards. and looking at the space traffic coordination and management regime to see in green where we have standards. It's sort of this gap analysis that Joanne was talking about. Yellow are our newly proposed ones that we're going to be working on. And then in red are some additional areas where, hey, we don't have a message yet. We might need to build those. Next. In the development of these data exchange standards, we're trying to make things better and more efficient. On the left column, you see the way it was probably 8 years ago, where you have in the standard, you have introduction, terminology, you have the actual definition of the message, and then the bottom you have definitions of reference frames and so forth. The problem is that every time you write a new standard, the terminology and the reference frames, all that stuff was inconsistent with each other. And every time they'd publish it, you'd have some conflicting information. So what we've done is pulled that out. And that's the green in the middle column. That's the new approach. And we've also made a lot of the content in these messages optional instead of mandatory. If you have 20-some thousand objects in the catalog, you can't afford to have for a single object all this mandatory content, especially if you don't need it in the first place. It's just unworkable. So we're trying to make things more efficient there. And then we're trying to head in the direction of what we call a super message, where you can take orbit and attitude and reentry and fragmentation, all these different blocks of data, and put them into one message. Next. SANA registry, this is another thing we're doing to increase efficiency. We're putting online normative content that allows us to get around this long latency, this long lag of building a standard, because things change, they're changing quicker and quicker. So we're putting content online to allow us to respond better. Next. Data exchange formats. CCSDS only uses key value notation, KVN, and XML. And these are old formats, and we get it. We've had a lot of questions within our navigation working group about, well, why can't we support some of the newer ones? Next. Like JSON, for example, or flat buffers is a good one. Next. But the reason we don't right now is that we have these volunteers that are supporting the development, and we need two organizations to test the messages in every format that the standard supports. And so the more formats we end up supporting, the more work it is to do. So right now, we're only supporting those two formats. But the good news is, once you have defined these values, these reference frames, timing systems, etc., it's fairly easy to then push that into a JSON format or something. Next. Now, the space environment is changing. It's not just because of new space. There's more bad actions going on. So now we have to, even commercial has to worry a lot more about data integrity, security, and quality, to ensure that their data is not being tampered with and is being properly understood. So that has to roll into these standards now as well. Next. Now let's move to best practices very quickly. Subcommittee 14 works on that. We have now 8 working groups. This is now out of date. We have another working group added, working on those different types of areas. Next. This is the kind of the makeup of these working groups. A lot of the space debris activities goes on in working group 3, which is operations, and working group 7, which is debris. Next. This is the working group 3 operations work program. You can see there's a lot of standards we're working on. Next. And then working group 7 also has a busy slate. Next. And then it's worth looking at the UN LTS guidelines, and a lot of them call for data exchange and standards. And it's worth considering how these two subcommittees address some of the calls for data standards. And you can see that this green means there's a lot of these clauses, which are the outer letters with a number in the LTS guidelines, do have a corresponding capability that's already a built standard. Next. And then I also want to talk about the UN. Well, the issue is that a lot of times people don't understand what a standard is. A lot of times it's felt that standards are the same as a best practice or a guideline. They're not, in my take. And as evidence of this, when I became the ISO liaison to UN COPUOS, and I looked on their website, they said standards. Here's all the standards. There wasn't a single standard on their website. There was national regulation, there was guidelines, policies, treaties, and so forth. So now we have added a lot of standards to that content. Next. So in summary, yeah, things are really evolving in space. Jonathan talked to a lot of these points, but it's not just new space. I will highlight for large constellations, we have what I call a conflict in best practice, because in the large constellation standard we're building, we have the principle that if you have many satellites, you want to launch them into a lower orbit, check them out, and then raise them up. Yes, they will fly through other constellations, but at least you won't deploy these dead satellites right up front, and then they'll be up there forever. That is in direct conflict with the visual brightness thing. And so it remains to be seen how that's going to be worked out. And as I say there, we have to standardize our terminology. We have to standardize how we exchange our data, and we have to standardize the best practices in support of all phases of the mission. I'll conclude there. Thank you.
Thank you very much, Dan. That was excellent. And I think you can see what an enormous amount of work that represents over the years. So thank you again, Dan, for all your efforts. So our third panelist, who I hope can hear us now, is Natalie Moore from the UK MOD. Natalie, are you receiving over?
I am receiving loud and clear. Thank you. Yes. Can
Lovely.
you hear me?
Thank you very much. So as promised, a sort of governmental voice on this international collaboration perspective now from Natalie Moore, who is the head of space policy. You were at the Space Directorate. Is that still how you're titled?
No, so I thought I might start with a couple of minutes on some of the changes within defence, if that's helpful.
Yes, please. And
Yeah.
Can I hand over the floor to you now, Natalie?
Of course, yeah. Thank you. So I'm Natalie Moore, Head of Space Policy for the UK Ministry of Defence. And I thought we've had a few changes in defence recently in how we manage the space portfolio. So I thought I'd just quickly explain how we fit together. So essentially, with Space Command now having passed its initial operating capability back in April of this year, that organisation has taken on responsibility for capability development and delivery, alongside the responsibilities it already had for operations and workforce generation. So what was the Space Directorate, which did policy and capability, is no more, and we're left with a space policy team within head office that sort of sets the strategic direction and the policy, but works very, very closely with Space Command on delivering against that ambition, delivering the defence space strategy, and with us holding them to account for that. So essentially the main change is that capability development has moved out of head office and into Space Command, as was always the plan. And we've sort of normalised the way we manage space in defence as a domain, with a sort of core directing responsibility in head office and the delivery out in the command. So I think this is a positive development, heading in the right direction in terms of space as one of our 5 key domains. So I was going to, so with that introduction then, I should say I'm not a technical expert like some of the speakers I think you've had today, but I was going to take a slightly different, slightly sort of more strategic approach then to how we view international collaboration from a defence perspective, and just reflect a bit on why that cooperation is so important. And I thought I'd start, I'm sorry, I don't have any slides, so no pretty pictures like the previous presenters, but I'll try and structure this so it's sort of easy to follow. And I just wanted to start firstly by saying that from a security perspective, international collaboration is really completely non-negotiable in space. The American space leaders like to say that space is hard and we can't address its challenges alone, whether that's from a scientific, a commercial, or a security perspective. And I think that's come through from previous presentations very strongly. Our allies recognise this, but I think even our adversaries have seen the benefits of collaboration. Just look at some of Russia's previous activity, including with the International Space Station. So I'll focus my reflections a bit more on the defence and security perspective, but inevitably taking in some of the scientific and commercial considerations too that were in the title of this session. And looking back to the Defence Space Strategy that was published in February this year, international collaboration was very much a theme running through that strategy, and it committed us to broadening and deepening multinational collaboration. It acknowledged that achieving defence's space ambition will require the closest possible international cooperation, and it talked about an international by design mindset. So why is that cooperation so important? And I'll talk about this under 4 main headings. Firstly, I think it's essential if we're able to understand, protect and defend the UK's interest in space. Secondly, it's absolutely critical for resilience. Thirdly, I think we can only together can we build stability and deter conflict from extending into space. And fourthly, I think there's a huge amount we can learn from each other and knowledge that we can share with mutual benefit in this very complex domain. So just to unpick those a bit more then. So firstly, in terms of protecting and defending our space interests, I think from our perspective, to achieve military advantage in the space domain, we need to be able to join up in our approach to capabilities and to operations. And space domain awareness was in our defence strategy as the second priority under satellite communications, because of the importance of being able to really first understand the nature of the threat that we're dealing with in that domain. And that has to be a joint effort across the range of orbits and drawing on the different geographies that different nations can offer. And one tangible example of this that we're working through at the moment is the deep space advanced radar capability that we're exploring with the US and Australia, potentially offering up some UK geography to that geo capability. And then intelligence, surveillance and reconnaissance is another key programme for the MOD. That's nearly a £1 billion programme, quite a large chunk of our new funding for space. But I think for me, the critical bit of this programme is not so much the satellites in space, but actually the digital backbone, which we're calling Minerva. And that's a very small, proportionately, a very small amount of funding, innovation funding, 120 or so million. But that's the really critical bit, and that's how we'll ensure we can plug and play into allied capabilities and into commercial capabilities, and scale up and scale down as necessary. And clearly, data sharing is a key part of what makes international collaboration so critical, because both the sharing of data and the processing of data is something that we can't do singularly. We also collaborate on SATCOM, and indeed we offer that into the NATO structures. And our collaboration in this area is very much a combination then of multilateral and bilateral efforts. So multilateral through a particularly key forum known as the Combined Space Operations Initiative. That's 7 nations, so the Five Eyes countries plus France plus Germany, who have a new vision that took some negotiating, but was published in February this year, and explains how we, as a group of 7, look across policy, legal considerations, operations, and capabilities in pursuit of a secure and a safe and secure space domain. And then on the bilateral front, we also have US are very much still a key relationship, and that's made clear in our strategy. But we're also strengthening and building up new bilateral relationships, including talking much more with nations such as Republic of Korea and Japan as we implement our strategy. And then the second theme was around resilience, and this is partly about the multilateral and bilateral collaboration that I just talked about, but also about commercial collaboration, I think. And the Ukraine conflict for us very much brought to the fore the value of commercial collaboration in space. Clearly, Starlink was game-changing in that conflict, and we saw very powerfully the impact of Earth observation data in debunking some misinformation and improving that atrocities had happened, looking at the Bucha massacre, for example. And much of this was provided through collaboration between nations and commercial actors. And again, our defence space strategy set out a model which was drawn from our integrated review earlier last year, the Own, Collaborate, Access model for looking at future capabilities, which means we need to really assess where we draw the boundaries between what we really need to own, what we really need to have on shore, and where we can collaborate with others on that, where we have a particular niche that we can offer, or where we can just access a commercial capability. And I think that's for us about understanding where the threshold is between the minimum military requirement that we would need to retain our operational edge in a conflict situation, and where we can, as I say, scale up and scale down, using that digital backbone to on the ISR front to plug into to allied and other capabilities. And then the third area was about deterrence. And this is really about how we work together to build stability and deter conflict from extending into space and keeping the domain safe and sustainable. And of course, we're talking here primarily about the threat from Russia and China. The US are fond of saying that China is the pacing threat, and we would agree. But Russia also has the potential to do a huge amount of damage in the space domain. And we saw that when they blew up their own satellite in November 2021, creating upwards of 1,500 pieces of trackable debris and many, many, many more. Excuse me. And some of our activity here includes the UK-led effort through the UN to establish some norms, rules and principles to reduce the risk of miscalculation and escalation. We've heard a bit about different types of standards, but we're focused here on the sort of voluntary norms end of that spectrum. And that's happening through the UN First Committee on disarmament and reducing space threats. And we've seen some early successes there, I think, including a new resolution that's been around to commit to not destructively testing direct descent ASAT weapons, with 154 countries voting in favour of that, in favour of that commitment, which shows a huge groundswell of endorsement to not creating debris through the destructive testing in space. I think that's a really, really positive step forward. Some other examples, so NATO last year declared that Article 5, the notion of collective defence, applies in space as it does in other domains, which is a hugely important deterrent message. And then I was just going to say a bit about the concept of integrated deterrence, which is outlined in the recent US National Defence Strategy. But in the UK, we've talked about this for a while too, in different guises, including modern deterrence, I think, was one we used recently. But essentially, we mean this concept of integrated deterrence. And I wanted to sort of outline that under 3 Cs, the 3 Cs of integrated deterrence. Firstly, comprehensive. So by that, we mean taking into account all of our levers of power and influence, whether that's military, diplomatic, economic, information related, and tailoring our approach to make sure we maximise the use of those that are best suited to change perceptions and deter actions of an adversary. The second C is coherent, so developing our deterrent strategies with an understanding of the way that those interplay across the spectrum of conflict and the temporal nature of crises. But most importantly, and relevant to this session, coordinated, so coordinated with our allies and partners so that the impact of our action is greater than the sum of its parts. And the US sometimes talk about entanglement here too, and that I think by that they mean that our our interests as allies are so intertwined that we produce both resilience and a significant deterrent effect for our adversaries. And so space can underpin deterrence in other domains, but an integrated approach is also hugely important in deterring threats to space systems. There must be better ways to deter space threats than using space systems, and we want to move away from a notion of space deterrence and this impression that you need to deter threats to space capabilities using space capabilities, which we do not believe is the case, hence this concept of integrated deterrence. And then my fourth and final theme then is about sharing knowledge and experience with mutual benefit, and to address some of the complex problems we face in the space domain. We can certainly learn from others that are more advanced, and we can share knowledge with those who are following closely behind us. And this clearly includes things like collaborating on research and development, science and innovation, to ensure we have the best technology at our disposal when it comes to things like sensors and antennas. And there's an example of this collaboration going on the first UK launch, hopefully taking off soon from Cornwall, in the form of our Prometheus 2 R&D payload, which is part of a collaboration, an R&D collaboration with the National Reconnaissance Office in the US and some other allies. But it's not just about technology. We're also sharing lessons internationally on structures and on governance. We get a lot of requests to talk about how we set up our Space Command and how that works, and lessons learned from that process. And Australia, for example, have followed a very similar path to us. We share a lot of lessons with them about how it's gone. So I'll conclude where I started then, in terms of international collaboration, and absolutely non-negotiable. This is a theme that comes through all of our engagement with allies on space. And I think we're realizing more and more just how critical it is if we're to be resilient, if we're to deter, and if we're to be able to protect and defend the space domain. Thank you, that was all from me.
Much appreciated. So I think we have just a few minutes to take a few questions on this section. Dins, do we have any questions from the online community? Just a second. I'll rendezvous with. Okay.
There are most statements, although there has been a few in the chat rather than in the Q&A. So yes, one of the early questions during this presentation was about actually Russia's involvement, or Russia and China's involvement in ASAT. There's more of a statement about should we be keeping an eye on nations such as North Korea. But there was a question from Jonathan McDowell actually for Dan about the working groups. And is there one that's actually looking at the relevance of the satellite brightness as one of the subjects they're looking at?
Yeah, great question. It's something I intended to actually talk about, because when I mentioned the large constellation standard, that's something that I specifically brought up to the group. Is this something that we should have as content in this large constellation standard? And I think we're faced with two things primarily. This is still an evolving situation, and we have, as I said, the clash of best practice that we're faced with. But it's also something where large constellations are out there, and we have to get something published quickly. So what we decided to do, and this was the consensus of the group, is to get a large constellation standard published and then focus on adding a section on visual brightness. Now, you know, could we have done it differently? Could we have focused on visual brightness first? I don't think, given the cadre of people we have working in that group, that would have been practical, but I would love to have your inputs moving forward. We'll probably have this thing published, I would guess, in a matter of 4 to 5 months, something like that is what we're shooting for, because we've already got to the kind of the near the final stage of the standard, and then we can immediately open it up. Usually there's a 5-year review for these things, But that's not to say you can't immediately open up a standard right after it's published, and that's what we can do there.
Thank you very much, Dan. Do we have any questions in the room for our panelists? I can see one over there.
Yeah, thank you. Following up on the last question, brightness. Is there any standard with regards to statics, electrostatics coming from the satellites envisaged in these standards? So any noise that any electric circuit will make? Because I mean, this relates to dark and quiet skies again, because in some they this can be quite large.
So there is electrostatics requirements for satellite design and building, but not for impact to others right now. And that's something, again, that can be added. I should say also, we've done our own research on impact of visual brightness on space situational awareness, because if you're trying to avoid collisions and you're trying to track objects, let's say optically, and something else flies in front of you, you can dirty your orbit solution, and then you could collide when you didn't intend to. Not that you ever intend to. So we looked at that aspect, but so there's a naked eye observing, there's astronomy, and there's this third category of just clouding your view of what is up there so you can avoid collision. All three are valid.
Just one or two more, I think.
Hey, I have a question for Jonathan. You kind of represent a group who have an interest in space and potentially, and I think you represent a lot of other people who also have a similar interest in space. And my question is, when you go with your problem to companies and to organizations and to governments, do you feel like you're listened to? And then for other groups who also adversely affected by things that are going on in space, would you have any recommendations for how they could go about dealing with it and bringing up their problems?
Right. Say there's a difference between being listened to and having your concerns actually acted on. I think that the companies that we've reached out to we've had cordial conversations with them. There has been some response and some action, but it's clear that ultimately the bottom line for the companies is going to override their sympathy for astronomers, and so we have to also go the regulatory route and engage with the regulatory authorities and point out that the various countries have a financial investment in astronomy facilities that's of interest to the taxpayer. So my recommendation to you, these other groups that you're talking about, is first, don't make the mistake we did. Get involved in the space governance stuff early. We were a bit blindsided by this on the optical community. The radio astronomers have been, on this for a long time and working with satellite companies. The optical astronomers, not so much. So get involved early in space governance. Build the links both to the commercial interest, but also to the regulatory avenues. And I think if you're not part of the conversation, then you won't be taken into account. And so I'm very heartened by Dan's comment that even though brightness isn't going to make it into this first rev of the large constellation standard, it's at least something that they're aware of and thinking about. And I think this we can talk about these conflicts of do you mitigate that with saying recommendations on fraction of your constellation that's in the low altitudes at any one time or something like that, right? There are ways. I don't think we don't want to ban these big constellations, right? We want to find a way to live with them, and so I think that there are productive conversations to be had on how to live together.
Yeah. Can we get a view from Natalie on whether that's a way forward seen from a military perspective, perhaps?
Sorry, I'm finding a way forward to live together.
Yes.
So I was also just going to reflect on Jonathan put a message in the chat as well on norms and the importance of persuading China to adopt those norms, which I think is a sort of related point. I think in terms of what we're doing on the through the UN, I think that is really about trying to I mean, you've got to start somewhere, right? So I think we're starting with trying to build a consensus with the nations that we can build a consensus with, and we're starting to persuade the international community more broadly about the value of doing this activity and the value of having these norms in order to try and prevent miscalculation in the domain. And I think you can't underestimate how much there is to do even to do that, to really educate on the nature of the threat and the nature of the domain. And lots of people just don't want to think about it. They think it's all just as it was sort of decades ago up there, and there's really nothing to worry about. And so I think what we have done is made a huge amount of progress in educating on that and the threats. And I really do think that this ASAT kind of resolution is a huge step forward in terms of kind of coordinating the international community against those actors who have capabilities to do that, and they were really the only people to vote against it. So I think that gives you then more leverage to be able to call these things out. So I think that's hugely important, but it's very much a sort of frustratingly slow progress. I think slow process. I think it has to be, because you have to take everybody with you, otherwise it won't have the impact. And I think that involves bringing in the like-minded nations before we can really sort of persuade our adversaries that this is the right way to go. But step by step.